Good morning, everyone. Today I'm going to do your mensuration. Last time I had just given the brief introduction about three solids that we are going to study, and those were the first one was cylinder, right? We have a cylinder here for you. This is a kind of cylinder. It has got two circular faces. Okay. Then second one we discussed was the cone. And today I'm going to discuss the third one, that is your sphere. So these are the three solids which will be in your syllabus for class 10. So yesterday in the cylinder we had already found the three formulas. So I'm just going to draw it roughly, the figures. This is the radius and this is the vertical height. So it has got two base here. So we have found the three formulas. The curved surface area, I'm writing in short form. So curved surface area was given as 2 pi RH, and pi here is the constant. Okay. Then your total surface area. The total surface area is in curved surface area is only this lateral face. If you take the total surface area, then you have to consider this circular as well as this circular. You have to take this as a solid, but here it is a hollow one. All right. So total surface area was 2 pi r bracket open h plus r, and the volume was the capacity. So capacity of the cylinder, and it was found to be as pi r square into h. Then we had also discussed the cone. So cone is nothing but it is similar to the cylinder, provided that one of the base is squeezed or it is reduced into a point. I did not get any sample for the cone, so I'm just going to roll it up, this one for you. So cone looks something like this. This has become a little bit clumsy. Okay, like this. So see, on the top you don't have anything, just point is there. So for the cone also there was one new nomenclature, which is a slanting height. This is slanting, inclined, and here also we have got three formulas. The curved surface area was pi r l, and the total surface area was pi r l plus the area of the base. So we had taken pi r common, l plus r. L is the slanting height, keep in mind here. And the volume of the cone will be same as the volume of the cylinder, provided you have to add 1/3, because the cylinder is, the cone is 1/3 of the cylinder. Now today we will be discussing sphere. All of you know this is a sphere is a round 3D object, like for example football. In the sphere also it is quite difficult to draw in the diagram, so I'm showing it like this. This is a center which will be inside, okay, and from there you have got a radius. So in a sphere the height can be also taken as the diameter, see. So in a sphere, now if you observe that in a sphere there is only one surface, so you have got only surface area in a sphere. The surface area for a sphere we know is given as 4 pi r square. Okay, the surface area of a sphere is given as 4 pi r square, because you do not have curved surface area here. So how it is calculated, this is not important for you, but only the applications is important. Now volume of a sphere is given by 4/3 pi r cube. 4/3 why means it is going squeezing this end, squeezing this end. So you have got a point here on both the ends. So these are the three formulas that you have to keep in mind. In the sphere also you have got a hemisphere. If I cut the sphere into half, it becomes hemisphere. Then you have a spherical cell. Spherical cell means the two cells will be there. One will be inside, another will be outside, and that portion will be only material, and at the center it will be vacuum. So that we will discuss later on. So now for the just to understand the concept, how the applications of formula is used, I will be doing some questions which are come from ICSE. Okay, look at this question here. The area of the curved surface of a cylinder is 4,400 centimeter square and the circumference of its base is 110 centimeter. Find the height of the cylinder and the volume of the cylinder. So here, which solid is there? Cylinder. So let me draw the diagram roughly here. Okay, this is the cylinder. You have, this is the radius and this is the height. The radius you can make at the base bottom also. So this is the, so now you will be given the area of the curved surface area. That means curved surface area, I'll write in the short form, CSA is given to you 4,400 centimeter square. Okay, so we know that curved surface area is this, and the formula also we have learned. The formula for the curved surface area is 2 pi RH. And the circumference of its base, is given to you 110 centimeter. Now what do you mean by the circumference? If you look at this circle, this whole distance is called the circumference, and you have learned in the previous class, in case of a circle, the circumference is given by pi r square. Pi r square is the area, alright, but the circumference of the circle is given as 2 pi r, which is equals to, how much is the circumference given here? 110. Now since the value of pi is not given to you, you have to use the value of pi as 22 by 7. So let us find the radius from here first. So what happened here exactly is, I have cross product, this 2 pi went down. In place of pi, I have substituted the value 22 by 7. So this 7 will go and reciprocate. So directly I am doing it here. So you can cancel 11 tens, 11 twos, 22, yes. Then 2 fives, 5 sevens, 35 by 2. So the radius is 35 by 2. You can write in the decimal also, that it will be 17.5. But here you are not asked to find the radius, you are asked to find the height. Find the height of the cylinder. So now to find the height of the cylinder, you take the curved surface area. So what is curved surface area given to you? Curved surface area is 4,400 centimeter square. Now you have to substitute the value of curved surface area. We have learned that the curved surface area is 2 pi RH equals to 4,400. Now here, if you see that 2 pi r, if you just observe 2 pi r, it is actually the circumference. So you can directly put there also. But we have found the value of radius. So you can put radius, you can put the value of pi also, or if you can see this clearly, if you can observe that 2 pi r is actually the circumference. So in place of 2 pi r, you can put 110 directly into height equals to 4,400. So from there 5h can be calculated easily, but let us do it in a conventional method. Pi is 22 by 7, radius you got just now 35 by 2 into h equals to 4,400. So now this 2 and 2 cancels, 7 5s are 35. See, you get the same answer. 25 into 22 into 5 is 110. So 0 0 cancel, 11. So 40 centimeter is the height of the cylinder. So what is the height of the cylinder? This 40 centimeter. Now the second question you have to find is quite easy. Number 2, you have to find the volume. Okay, see here, volume of the cylinder you have learned is pi r square h. Now here, why I have found the r is because we have to substitute in calculating the volume. So pi is 22 by 7, radius is 35 by 2. Since it is a square, you multiply by 2 times. 35 by 2 into 35 by 2. Height you have just found is 40. 2 11s are 2 20s are 2 5s are 35. 11 5s are 55 into 35 into 20. 55 into 700. Okay. 7 5s are 35, carry over 3, 7 5s are 35, 36, 37, 38. So the volume of the cylinder is something like this, 38,500 centimeter cube. Now here the most important is the formula and the values given to you. What are the two things given here? Curved surface area and the circumference of the base. Now you understand the circumference, I am telling it again. This is the circle and the circumference is this total length. We know that in a circular, what is the total length? 2 pi r. What is the area of this circle? Area of the circle we know is pi r square. So like this you have to solve. So let me solve one more question there. Okay, and this is also from the cone. Since we have done the cylinder, look at the question. This is also somewhat similar to what we did just now, only the solid is different here. See, the volume of a right circular cone is 9856 centimeter cube. So volume is given to you. If the diameter of the base is 28 centimeters, the diameter of the base is given to you. Find the height of the cone and the curved surface area. So this CSA is curved surface area of the cone. Given, so we start with the diagram. Okay. This is the cone, this is the radius, and this is the height. So in this question, the volume is given to you, 9856 centimeter cube, and the diameter of the base is given to you, 28 centimeter. Now what do you mean by diameter of the base? See, this is the base. Now suppose this is a cone, alright, it is squeezed like this. Then diameter, we don't require diameter is this full distance. We don't require diameter, we require radius. So radius is half of diameter. So from here, first you calculate the radius. 28 by 2, that is 14 centimeter is the radius. So we got the radius here. Now look at the first question, height of the cone. So let us take, what is the volume of the cone? See, what is the volume of the cone? We have learned the formula. The volume of the cone, if you remember, the volume of the cone is same as the volume of cylinder, only you have to add 1/3. See, 1/3 pi r square volume of the cone. Alright. So now what you do is, in place of the volume, you write down the formula 1/3 pi r square h equals to 9856. Now this is the height we have to find. R is already given to you 14. So let us substitute. Pi is 22 by 7. The value of pi is not mentioned here anywhere. So you have to assume that pi is 22 by 7. Radius you have just found to be 14 into h, 9856. So you can start cancelling. 7 2s are 14. Okay, so h will be 9856. 3 will go up, 22 into 2 into 14. So if you do this cancellation, you can get the answer quickly. So if I think this can be cancelled by 11, 8s are 88, 10, 105, 11 9s are 99, 6, 11 6s are 66. Okay, like that you can cancel. Then you can also cancel this by 2. 2 4s are 8, 2 4s are 8, 2 8s are 16. You can cancel this by 2. 2 7s are 14, 2 2s are 4, 2 2s are 4, 2 4s are 8. I think you can cancel this by 7. 7 3s are 21, 7 2s are 14. Therefore the height is 3 2s are 6, 3 3s are 9. So we got the height of the, what do you call, the height of the cone is 96 centimeter. Now you have to find the curved surface area of the cone. If you remember, the curved surface area of the cone is given as pi RL. Pi is 22 by 7. Radius you just found to be 14. Now where is this L? L is not given here. So what is L? L is the slanting height. See, this is the L. Okay, so this L, the height and the radius is given to you. So now we have learned one relation. What was that? It was the Pythagoras relation, L square equals to h square plus r square. So you have to put the value of h square there and r square, then you can find the answer. 96 square plus 14 square. So like this you calculate this. I'm not going to do it. You have to find the value of L. 96, how much will you get? 96 square. So this will be quite a big number, so you need to solve it fast. Okay, let us do here 96 6 36. Okay, you do it yourself, and let us say some value is found here. Okay, I'm not going to do that. So L, let us assume that L is 18, for example. It is not correct, it may be 18 also. Now you have to find the curved surface area. Therefore the curved surface area of a cone is pi RL. So pi we got 22 by 7, radius you got 14, and L you have to put here whatever. This 18 is not correct, I'm just giving as example. So you put the value of L here, cancel it and multiply. That will be a curved surface area of a cone, and it will always be in the unit square centimeter or the square unit. So basically in the mensuration you have got three solids only. What happened to this cylinder? You have got cylinder, you have got a sphere, you have got a cone. I did not get a sample. And in the sphere also you have got a hemisphere, that I am going to discuss later on. So we have got one more question there. Okay, let me solve that also. This is slightly different from what we did the first and the second. Here you have the conversion, the what you call one solid changing into another. So let me explain that briefly first, then we will proceed to this exercise. Okay, suppose I take one cylinder, a metallic cylinder is there. All right, now this metallic cylinder, suppose if it is heated and it is melted. All right, it is melted and you recast and you make it into another solid. Let us say we have changed it into cone. See, the same material, nothing has been wasted. Same material, it is converted into a different solid. So in this process, whatever you are doing, you are converting one solid into another solid. So in the process of this, what do you think will remain same? You have to keep that in mind. See, nothing has been wasted here. So the curved surface area will not be same because they are not the same. They are two different solid. Okay, so what do you think will remain same? You have to think about that. Okay, I'll tell you. The volume of the cylinder will always remain. The volume of the solid will always remain same. That means the volume of cylinder will always become equal to the volume of cone, no matter in what solid it is converted. It can be converted to sphere also. So when it is converted to sphere, it can be, the volume will remain same. And another second condition can be like this. Suppose this solid is melted and it is recast into different number of spheres. Now see, suppose this cylinder, it is melted and it is reshaped and you have made five spheres. Okay, suppose you make more than 5 spheres also. So in the process here also, what is happening? The volume is remaining same, but one difference will be there. In the first case, what happened was one solid was changing into another one solid. So therefore volume of one cylinder will be equals to volume of one cone. But here one solid is changing into 5 different solid, but all the solid, now provided they are same size, so it will be volume of one cylinder will be equal to volume of 5 spheres. Likewise, from the cylinder, if you change it into n number of spheres, then volume of cylinder will be equal to volume of n spheres, n number of spheres, provided that the size of the spheres remain same. So using this concept, I am going to solve the next question for you. A certain number of metallic cones, each of radius 2 centimeter and height 3 centimeter, are melted and recast into a solid sphere of radius 6 centimeter. So here also it is not given how many cones. So for the cone, let me just draw roughly. For the cone, what is given to you? The radius of the cone is given to you 2 centimeter. The height of the cone is given to you 3 centimeter. Alright. Then there are certain number of let us say there are n number of cones. We don't know how many cones, but all the cones are of same size. So how many cones are there? N cones, n number of cones. So these cones are melted. It is melted, see, melted and recast. So you melt all and you make it, like in case of that what a Terminator, when that the actor is melted and again everything gets joined, and again he is come into life, like that. So you are melting it and again you are making it into a solid sphere. So one sphere you are making. So this is a solid sphere. So all these cones, we don't know how many cones are there. They are all melted and made into a solid sphere of radius 6 centimeters. So let us take the radius of the sphere as capital R, just to you differentiate between the cone and the sphere radius. And how many sphere you are making? You are making one sphere. So therefore, what do you write? Volume of cone into, because all the cone are same. How many cones are there? N equals to volume of sphere. Now you have to find n. N is the number of cones. So it's quite simple. Volume of sphere will be divided by volume of cone. Now this is a single cone, but this n is the number of cones. We do not know how many cones are there. So that cone is melted and made it into one sphere. So you have only volume of one sphere. So now put the formula. The volume of the sphere you have learned. It is 4 by 3 pi r cube. Volume of the cone is 1 by 3 pi r square h. Okay, so you substitute 4 by 3 pi. Radius of the sphere pi r cube. Yes or no? Yes. Volume of the cone is 1 by 3 pi r square h. This pi and pi cancel, 3 and 3 cancel, so you are left with 4. Radius of the sphere is 6 into 6 because there are r cube. Then down there, radius of each cone is 2 centimeter, 2 into 2. Then height of each cone is 3 centimeter. There will be no unit here because you are finding the number of cones, so no unit. Unit is cancelled. 3 2s are 6, 2 2 cancel. So also 6, 2 2s are 4, 6 6 2 6 are 8, 36, 12. So you can make 72 cones. So there has to be 72 cones. Okay, 72 cones, you bring it. All the cones are of same size, radius 3, height radius 2, height 3. Then you mix them up, you melt them, you mix them, and you change it into a sphere. So that will be here. And so this type of questions are very, very important. If you see in the ICSE, mostly the questions will come from this type. That means the conversion of one solid into another. So Just again a quick recap. When one solid cylinder is melted and it is recast into one cone, then the volume of this solid cylinder will be equal to the volume of the cone. In another situation, when the number of solids are again melted and recast and made into one cylinder, then the volume of this number n into volume of this will be equal to the volume of one cylinder. So we will be doing this more in the next class. This much for today. Keep on practicing. Thank you very much.